In this chapter, we will study the structure of AS400 database files. We will also see how the files can be defined to the system and also how to create these files. Traditional database files are said to be program described. The data definitions are included in each of the programs that use the database files. Suppose you increase the length of a particular field. The change would have to be reflected in each of the programs that use the data. AS400 database files, on the other hand, are externally defined. The data definitions are stored along with the data itself. Programs that need to use the data will only contain a reference to the database file. The compiler will pull in the data definitions from the database file when the programs are being compiled. Any changes that are made to the format of the data will have to be made only in one place, that is, in the database file itself. The data definition includes the library name that contains the database file, database file name, database file type, database file subtype, and the user profile that owns the object. Physical files, as you have already seen, are the AS400 objects that store the actual data. Each file has a single record format. The record format describes the format of the records in the file. A physical file can have multiple members, with each member containing a portion of the file's records. To create a physical file, we first code the data descriptions using an editor such as source entry utility. The descriptions are then saved to a source file. Next, we use the create physical file command to create the file. Data description specifications, or DDS, are used to describe externally defined objects such as database files, display files, and printer files. The source files are used to store the data description specifications. We use the create source physical file command to create the source file. There are some naming conventions that are normally followed for source files. The source file used for storing data descriptions is usually named QDD-SSRC. This enables the system to supply the correct object type to the editor so that interactive syntax checking can be done. For example, QRPG-SRC for RPG programs, QCL-SRC for CL programs, QCMD-SRC for command definitions, etc. Also, the create physical file and create logical file commands take a default value of QDD-SSRC for the source files. Getting back to physical files. Keep in mind the following tips when coding database files. File names, record format names, and field names should not exceed 10 characters. Only uppercase characters are allowed. The first character in a name should be an alphabet. The remaining characters should be alphabets or numbers. The @ $, hash, plus, minus, and the underscore characters are also allowed. However, the $, and hash symbols are part of the national character set, which could vary for different countries and hence are best avoided. Also, you should take into consideration the limitations of high-level languages. For example, RPG 400 and COBOL 400 do not support the underscore character. This is a DDS coding sheet that you can use to code the data descriptions before entering it on the system. DDS uses a position-sensitive format. Let us write a description for a physical file. Say, for example, we want to create a database of customer information. In the database, we will store the following information: customer ID, customer name, customer address with street, location, city, PIN code and state. Also, we would like to sequence the file on customer ID. First of all, we give a name to the record format, say customer format. We write this in columns 19 to 28. We write an R in column 17 to indicate that the entry in columns 19 to 28 is a record format name. Next, we define each of the fields in the record format. When defining fields, we leave column 17 blank. After defining the fields, we define a key field if we want to use a keyed access path for the file by writing the name of the field in columns 19 to 28 and a K in column 19. In columns 30 to 34, we define the length of the fields. This has to be written right justified. This entry is valid only when defining fields. Columns 36 and 37 are used to indicate the number of decimal positions in a numeric field. In column 35, indicate the data type of field. And indicates a character field. Z indicates a packed decimal. We will see more about that type in a little while. 38 is used to indicate the valid operations that can be performed on the field. For physical files, we can use B to indicate both or leave it blank, as both input and output operations are always valid for physical files. In case definitions for a field already exist in a previously defined file, we can avoid having to define it again by specifying an R in column 29. We also have to identify the file in which the definition exists, but we will see how to do that later. Columns 45 to 80 are used to define keywords that are used to enhance the functionality of DDS statements. We will see more about keywords in a little while. Unique. This keyword is placed at the beginning of the file. It prevents two records in the same physical file member from having the same key value. For example, in our customer file, we should not have two records with the same customer ID. Remember, earlier we had said that you could avoid defining a field that has already been defined elsewhere by putting an R in column 29. We use the reference keyword to identify the file that contains the field definitions. For example, here the customer reference file will be referenced for the definitions of the street, location and city fields. When keywords appear at the beginning of the file before any record format definitions, they are referred to as file level keywords. They affect the entire file. Similarly, keywords that appear at the record level, that is either on the same line as the record format definition or before any of the field definitions, are called record level keywords and are applicable only to this particular record format in the file. The text keyword is used to specify descriptive text for the record format or field. The description is coded within parentheses like this. Next, we come to field level keywords. These keywords are associated with a particular field and affect only that field. The column heading keyword is used to specify a column heading for a field that is used when generating reports or running a query on the file. The column heading can be a single, double or triple line. Here's a 2-line heading. Next we move on to the key field level keywords. These keywords define how DB2 400 should handle a field when it is used as a key field. The descend keyword specifies that the key field should be in descending order when the records are sequenced. Otherwise, the default is ascending order. Let us now see how to code and create a physical file. First of all, use the change current library command to change the current library to the one in which we want to create the files, like this. Next, use the create source physical file command to create the source file. Next, start the program development manager using strpdm. Select option 3 to work with members. Supply the source file name and the library name. For members, and type specify *all. This will display all the members in the source file. Press the enter key. Right now there are no members in the source file, but later on, as more members are added, you will get a listing of all the members that have been already added to the file. When you press the F6 key to add a member, you will be prompted for the name of the member and the source type. Normally, we will give the source member the same name as the physical file we are going to create. The text parameter is for documentation purpose. Pressing the enter key will take you to the editing screen. Enter the code for the physical file and press F3 to exit. You can now see the exit screen with all the values filled in correctly. From here, you press the enter key to go back to the work with members screen. The next step is to create the physical file. There are two ways of doing this. You can enter a 14 in the option field adjacent to the member name, or you can type in the create physical file command on the command line. Either way, pressing the F4 key will prompt you for the parameters of the command. Let us look at some of the parameters. The file parameter is where you specify a name for the physical file. Normally, we would use the same name as we have given to the source member. Use a qualified name to ensure that your file is placed in the right directory. The source file parameter identifies the file where the DDS source is stored. It has a default value of QDDSSRC. The member parameter is where we supply a name for the member in the source file. This parameter has a default value of *file as the member name is normally kept the same as the file name. In the maximum members parameter, you specify the maximum number of members you want for the physical file. The authority parameter specifies the kind of authority that public should have to access this file. Finally, we come to the text parameter where you can code a description for the file. Once you have specified the parameters, press the enter key to create the file. If there are no errors in the DDS code, the physical file will be created with a single member. To add more members, you can use the add physical file member command like this. If we want to add more members to the file than had been specified with the maximum members parameter, you can change the maximum members parameter like this. The change physical file command can be used to change many of the other attributes of the physical file after it has been created. The create physical file command creates a file with a single member. Logical files. Logical files, as we have seen in the first chapter, do not contain any data. They are used to view the data records that are in the physical files in formats that might be different from the way in which the records are actually stored in the file. Programs that use logical files will see the data in the physical file as per the format of the logical file. By selecting only the necessary fields, we can prevent end users from having total access to the information in the databases, thereby providing a level of security. Let us see how logical files are coded. Let us take the same customer physical file that we saw in the previous chapter. Now, say an application requires the following fields from the physical file: customer ID, customer name, and city. Also, the application requires that the records be sequenced on the city field. Let us see how to code the logical file so that it meets these requirements. Like for physical files, we code a record format name in column 19 to 28 along with the R in column 17. In the function column, we code the p-file keyword to identify the physical file that contains the data. Next, we list out the fields we want to include in the logical file. Then we define the key field city by putting a K in column 17 and the field name in column 19 to 28. This completes our requirements. We can now create the logical file. Applications using the logical file will see only the fields that are coded in the logical file. Now, suppose an application requires all the fields from the physical file but sequenced on the customer ID field, then we code it like this. Here we use the same record format name as in the physical file, and as before we specify the p-file keyword along with the name of the physical file. Next, we identify the key field on which to sequence the file. This is all the code that is required. When we do not specify any fields in the logical file, we are sharing the record format of the physical file. The select omit logic can be used to select a set of records that match a criteria. Select omit entries are placed after the key field specification in a logical file. For example, to select only those records of customers who reside in Mumbai city, we code an S in column 17 for select. We code the field name city in columns 19 to 28, and in the function column we code the compare keyword. The value of the city field in each of the records is compared with Mumbai, and only the matching records will be selected. The omit logic works in a similar manner. We can, for example, say omit all the records where the city is equal to Mumbai. As you can see, the compare keyword takes two parameters, a relational operator and a value or field name. The relational operators that you can use with the compare keyword are less than, not less than or equal to, greater than, not greater than or equal to, and not equal to. The range and values keywords can also be used with select omit statements. The range keyword takes two values, the lower and upper limits that have to be tested for. For example, here we say select all the records where the balance amount is between 20,000 and 60,000. The values keyword can take a set of values. For example, Here we are selecting all the records where the category field has a value of A, B or C or D. The process of coding and creating the logical files is the same as in the case of the physical files. Here you use the create logical file command instead of the create physical file command. Next, we look at a special kind of physical file, the field reference file. This is a very useful tool for application development. Let us see how it works. Most database applications involve more than one database file. Many of the fields used by the application will appear in more than one file. A field reference file is a physical file that can be used to hold only field definitions. We can put the data descriptions for all the fields required by our application into a field reference file. All the database files will now refer to this file for data definitions. This method provides a consistency to our data definitions and also reduces the probability of errors caused by incorrect definitions. We code the field reference files just like we code the physical files. We have a record format name and then we define all the fields that we want to include. We use the create physical file command to create the field reference file. The members parameter should be set to none so that DB2 400 does not allocate any space for data records since the file is not going to contain any data. After the field reference file is created, you can refer to it for data definitions required in the database files that you will be creating. This brings us to the end of the discussion on physical files. In this chapter, we saw how externally defined database files were described to the system. We looked at the different types of database files supported on the AS400, namely the physical and logical files. We saw how to write the data description specifications for the database files and to create the files using the data definitions. We also looked at the field reference file, which is like a central storehouse for field definitions that can be referred to when describing the database files needed in an application.